In this lesson, we are going to take a look at the supply function and the demand function, and we're going to learn how to use those to find the consumer surplus and the producer surplus. Now, when we look at this graph, if we look at the axes, the X represents the number of items, and the Y-axis represents the price. So, and then you see this point here, the X with the little sub e, and P with the little sub e. And this is when we have a number of items, that's your X, and P is the price, but the little e is down there to specifically point out that that's what's called the equilibrium point. So that's where the supply and the demand curve intersect, where they're the same. We are first going to look at consumer surplus. And we are going to abbreviate consumer surplus with the CS. And you'll see that notation throughout the book and throughout your homework, so just to make sure you know what that means. Now, consumer surplus is what's going to make the customer very happy. So this is when what the customer is willing to pay is larger than what they end up actually paying, then they're saving money. So there's a positive difference between what they're willing to pay and what they actually pay. So specifically, let's look at X is equal to 100. So here's a point, X is equal to 100. And when we plug that into our demand curve, we get that the customer is willing to pay $5. So anywhere on that demand curve, if we plug in a specific value of X, which is the number of items, we will get out what the customer is willing to pay. Now, if the customer ends up actually paying $3, so along this horizontal line that passes through this equilibrium point, that's the actual cost that consumers paid. When the customer actually pays $3 and they thought they were going to end up spending $5, that's going to make them happy because the difference is $2. They're saving $2. So there's the difference. I take 5 and then minus 3. So they're saving $2. Now, if we want to talk about finding the entire accumulative area, that's in here. So all the money that customers are saving between 0 and that equilibrium point, that's when we use integration. And we've been practicing that. We've been practicing finding the area under the curve and then the area between curves. And if we want to find that green area, that's the difference between the demand and then the price that they actually pay. So what we would do is we would integrate from 0 to whatever that X value is for the equilibrium point. In this example, it would specifically be 300. And then we would take the demand curve, that's the D right here, this D line. And then we would subtract the price, which is this function here. And that, when we integrate that from 0 to wherever the X value falls for the equilibrium point, that will give us the entire green shaded area. Now, we're not going to talk about what happens on the right side of the equilibrium point. So once X passes that equilibrium point, the consumer surplus and the producer surplus isn't really going to be there. It's going to be a situation where they're not going to be saving money. So if we look at that specific value, X is equal to 500. And so this is what the customers expect to pay, or what they're willing to pay. So they're willing to pay $1. But if they actually end up having to pay $3 and the market price is $3, then they're actually having to pay $2 more, that's this difference, than what they expected or was willing to pay. So in this area here between the equilibrium line and the demand function, this area isn't going to make anybody happy. So we're going to call that the no-go zone. And then we have a similar situation for up here when we talk about producer surplus. So we're going to use this formula where we go from 0 to whatever the x value is for the equilibrium point, and we subtract the difference between the demand and the price, and that's going to give us that total green area, which is the consumer surplus. Now looking at the producer surplus, we're going to abbreviate that with PS. So when you're looking at the producer surplus, that's going to be where there's a difference that benefits the producer, where it's what the customer paid versus what they were going to ask for that item, what price that they were planning on charging. And so that's going to be in this yellow area here. That's where the producer benefits. So if we wanted to find specifically at x equals 100, let's try that again. So at x equals 100, this is going to be the price that the customer actually pays. This line right here tells us the market price. So at 100, this is what the customer is actually paying, $3. But the producer was going to ask for $1 for that item. So now the producers are very happy because they're getting an extra $2 than they originally expected. So that would be this difference here. So if I take the market value, which is 3, and subtract the $1, the difference is that the producer is saving $2. If we want to find that entire shaded yellow area, we want to find the accumulative producer surplus from 0 up to 300 in this specific example, but just in general, we would look at the x value of the equilibrium point. So we're trying to find that area, and again, we've been practicing that. To find the area between two functions, we use the limits of integration. We look at what values that would cover for the x, and we would go from 0 to whatever that x value is for the equilibrium point, and then we would take the upper function and subtract the lower function. So the upper function in this case is 3, but generally speaking, this would be the market price. And then you subtract the supply function. So this is what we're going to use, that integral, if we want to find the accumulated area. So now looking at the right-hand side of the equilibrium point, again, this is going to be where people are not happy. So if we look at 500, which is to the right of the 300 for the equilibrium point, that's what the customers are paying, $3. However, the producers were expecting to receive, or was going to ask for, $5. So the producers want $5. The customers are going to pay $3. So the producers or the sellers are not going to be happy because there's a difference of $2 from what they expected to what they're going to get. So again, that difference in that area here, we're going to call that the no-go zone. So we're not going to be focused on anything really to the right of the equilibrium point. For our first example, we're going to find the consumer surplus, and we're given that the demand function is 1,450 minus 3x squared. And we're also given that the price is $2.50. So when we look at the graph, in green we have our demand curve, and then this purple line represents the price at $2.50. So because the demand curve represents the price that the consumers are willing to pay, and this is the price they're actually paying, that means they're willing to pay more because the demand curve is above. They're willing to pay more than what the price actually is. So this is where the consumer is going to save some money, and they're going to be very happy. Now, in order to find this area that's enclosed by the demand curve and the price, we need to find this equilibrium point so that we can find our upper limit for integration. We know we're going to start at 0, but we just got to find out what this point is. And we can already see on the graph that it's 20 because I showed you the graph. But to find it algebraically, we want to find the value of x where the demand is equivalent to the price. So if we set 1,450 minus 3x squared is equal to 250 and we solve for x, if we combine our constants, we're going to get minus 3x squared plus 1,200 is equal to 0. This is a quadratic, so you can either use quadratic formula where the x term has a coefficient of 0 because you don't see any x term there. Or you can use complete the square, but the method in this case that I would prefer to use is just taking the square root of both sides because it's set up for us to be able to do that. So if I subtract 1,200 from both sides, then I'm going to have negative 1,200 on this side and negative 3x squared left on the other side. So all we would have to do is divide negative 3 on both sides, and we would get x squared is equal to 400. And then when we take the square root, we would get that x is equal to negative 20 or positive 20. Now, because we don't want to consider the case where we have x is equal to negative items, that doesn't make sense in this context, we are going to eliminate that as our x value, and we're only going to keep the positive value. And that is where we see that intersection point right here. So now we can say that we know what our coordinates are for the equilibrium point. So 20 is our x and 250 is the price. So 20 items and 250 for the price. Now, because we're trying to find the consumer surplus, we want to see where consumers are going to save some money. So that's going to be when the demand is larger than the price. The demand curve shows you what the customers are willing to pay, and then this is the actual price in purple. So if the consumer is willing to pay more than what the actual price is, then they're going to actually save some money in their mind. So this whole area is going to be where the consumers are going to save money. So this is the area that we want to find. If we were just looking for one point, we could just find the value at that one point for the demand function and subtract 250. But we want to find the accumulated value of the entire consumer surplus. So now that we have our x coordinate for x is equal to 20, you're going to go from 0 to 20, and you're going to find the difference between the demand curve and the price. So we're going to have 1,450 minus 3x squared, and then we're going to subtract 250. When we combine these two values, we're going to get 1,200 minus 3x squared, and we're going to integrate that from 0 to 20. So when we find the antiderivative, we're going to have 1,200x minus x to the third. And when we evaluate that from 0 to 20, we're going to get 16,000 minus 0. When we plug in 20, we're going to get 16,000. And when we plug in 0, we're going to get 0. So the total amount that the consumer is going to save is going to be 16,000. In example 2, we're going to find the consumer's and the producer's surplus, and we're given the demand function and the supply function. Now I graphed them ahead of time, both those functions, so that you have a visual aid while we're doing this, looking at the graph. Now because we're going to be looking for area using integration, we need to find what this equilibrium point is so that we know what our upper limit of integration is. We know that we're going to start at 0, but we got to figure out how far we go out with our x's. Now right now, because of the graph, we can estimate it that it's between 50 and 60, But in order to find that exact value, we're going to need to set the two functions, demand and supply, equal to each other. And then we're going to solve for x. And that will give us the x-coordinate of the equilibrium point. So setting the two equations equal to each other, we have 0.004x squared is equal to 25 minus 0.005x squared. When I add 0.005x squared to both sides, I'm going to get 0.009x squared is equal to 25. Then I'm going to divide both sides by 0.009, and we'll get x squared is equal to 25 over 0.009. Then when I take the square root, I'm going to get plus or minus 52.7. And you can see that makes sense based on the graphics in that area. So make sure you verify it. Now we have the x-coordinate of our equilibrium point. We also need to know the y value so we can subtract what the customers are actually paying. So that we know what the customers are paying. That would be this line right here, this horizontal line. So because at this point right here, the equilibrium point, the price is the same for demand and supply. So you can plug your x value for the equilibrium point into either function and you'll get the same answer. Now, because the supply function has only one term, I thought it might be easier to plug it in there. But you could plug it into the demand curve too and you'll get the same thing. So we know that our x value at that equilibrium point is 52.7. And then when we plug it in, I got 0.004 times 52.7 squared, which gives us approximately 11.11. So now that we know our complete equilibrium point, we know the x and the y. So that is this point. And so that's the 52.7 and 11.11 for the y. Now, when we're looking for the consumer surplus, we're looking for the area where the consumers are willing to pay more than what they're actually paying, because that difference will benefit the consumer. They'll be happy that they're saving some money. So that's this blue area that we're going to be looking for. Then when we're looking for the producer's surplus, that's going to be this green area, because that is where the producer is getting more from the customer than what they were expecting. So this is what they were willing to price the item at. This is the green curve. And then the customer is actually paid, and that's this line here. So the difference for that would give the producers a little extra money and would make them happy. So because we're continuing this on the next slide, I wanted to bring over the equilibrium point. And we're going to start with finding the consumer surplus. So remember, if you look back at the previous slide, the consumer surplus is the area that's trapped between the demand curve and the price that customers are actually paying. So we need to take the demand curve, let's see, this right here, that's our demand curve, and subtract the price. And when we set up our integration, we get, let's see, we have the 25.005x squared minus 11.11. But when we combine that 25 and 11.11, that gives us 13.89. So we just combine those constants. So now we have it set up a little bit easier. And we're going to find the antiderivative of negative 0.005x squared plus 13.89. When we find the antiderivative, we're going to get negative 0.005x cubed divided by 3 plus 13.89 times x. And then we have to evaluate it from 0 to 52.7. You have to evaluate the 52.7 first. And when we do that, we get 488.06. And then when we plug in 0, we get 0. So when we subtract them, we get that the consumer surplus is 488.06. Now looking at the producer surplus, that is the area that's trapped between the price that customers are paying versus what the lowest point that the producers were willing to price that item. So we're going to take that price that the consumers are paying and subtract what the producers were willing to drop the price down to. And so what that difference is, the producer is going to be happy because they're going to be getting more from the consumer than they expected. So when we find the antiderivative, we're going to get 11.11x minus 0.004x to the third over 3. And then when we evaluate that from 52.7, and we plug in that 52.7, we're going to get 390.35. And when we plug in 0, we're just going to get 0. So we're just going to be left with $390.35. That will be our producer surplus. In our last example, we are going to, again, find the consumers and the producer surplus. And in this particular example, the X is going to represent glassware, and it's going to be in the thousands. And I added that in up here in the corner. It's going to be in thousands. So we're given the demand function, negative 0.001 x squared plus 154. And we're given the supply function, which is 0.0002 x squared plus 0.03x plus 100. So in order to find the consumers and producer surplus, since we're not finding it at a particular point, we want to find the accumulated amount that's trapped between two functions. And for the consumer surplus, we want to find the area that's trapped between the demand function and the price. And then for the producer surplus, we want to find the area that's trapped between the price and the supply curve. So in order to set up those integration problems, we need to make sure that we know where the limits are for integration. And we know that we're going to start at 0, but we got to figure out how far we come out this way. And that's why we need to find that equilibrium point. So that equilibrium point happens where the degree and the supply functions intersect. So the first thing we're going to do is set them equal to each other and solve for x. So when we set them equal to each other, we have 0.002x squared plus 0.03x plus 100 is equal to negative 0.001x squared plus 154. Now we're going to move everything to one side and set it equal to 0, so we have a quadratic to solve. And then we can use whichever method we want, quadratic formula, complete the square, factoring, whatever your preference is. And once you solve for x, you're going to get negative 255 for x, or x is 200. Now, because we're talking about a number of items, specifically glassware in thousands, we don't want to use the negative value because that doesn't make sense. So we're going to stick with just using x is 200. So the x value of our equilibrium point is going to be 200. Now, to find the corresponding y value, we need to plug 200 into either the demand function or the supply function. Now, it doesn't matter which one you plug it into because at that equilibrium point, they're both going to be the same. So my advice is to plug it into the one that you think is going to be the easiest one for arithmetic. But either way, you should get the same answer. So we're going to get 114 for that. So this point right here is 200 and then for X, and then Y is going to be 114. So there's our intersection point. Now, when we look for the consumer surplus, that's going to be this area here highlighted in blue. That's going to be the area that's trapped between the demand curve and between the price. And that's because we're looking for the difference between what the customer is willing to pay versus what they actually paid. And that extra difference is going to be a benefit to the consumer. It's going to be extra money in their pocket. Now, when we find the supply surplus, or sorry, the producer surplus, that's going to be here in green. And so now we're going to find the area that's trapped between the price and the supply. And so let's go ahead and do that on the next page. Now that we found the equilibrium point, which is 200 and 114, we can actually go through and find the consumer and producer surplus now. So to find the consumer surplus, that is the difference between the demand and the price. So when we're looking for the difference between the demand and the price, that is the difference from what the customer is willing to pay versus what they actually paid. And so when there's a difference in the positive for that, the consumers are going to be happy because they're saving money. So we're going to take the demand function and subtract the price and then integrate from 0 to 200. So the demand function is negative 0.001x squared plus 154, and then we have to subtract the price, which is 114. Now, the 154 and the 114, those can be combined and we get 40. And then when we find the antiderivative, we get negative 0.001x cubed divided by 3 plus 40x. Now we have to evaluate it between 0 and 200. When we plug in 200, we're going to get 5,333 and 33 cents. When we plug in 0, it's just 0. So for the consumer surplus, it's going to be 5,333.33. Now to find the producer surplus, that's the difference between what the customer pays and what the producer is asking. So when that is positive and it's a bigger number, then that means the producer is saving some money. And so to find the difference between the price and the supply function, we're going to take 114 minus, that's the price, and then the supply function is 0.0002x squared plus 0.03x plus 100. Now we can take the 114 and subtract the 100 so that they're combined. That's this, and then I can subtract 100. That's going to give us 14. And then don't forget this negative has to also apply to the first and second term of the supply function as well. Now, when we combine like terms and we find the antiderivative, we're going to get 14x minus 0.03x squared minus 0.002x to the third divided by 3. When I plug in 200, I'm going to get 1,666.67. And when we plug in 0, we just get 0. So our producer surplus is going to be 1,666 and 67 cents. So let's sum up the major points of the lesson. So when we're considering consumer surplus, that is when the consumer saves money or the buyer saves money because what they expect to pay for a product is a lot more than what they actually paid. So the consumer ends up saving money and it makes them happy. So when we're looking at the producer surplus, that's when the sellers are happy because what the consumer actually pays is bigger than what they had thought that they were going to sell the item for. So the producer is happy because that's saving them money as well. Both surpluses happen because there's a difference between what is expected and what you actually end up paying. And then lastly, the equilibrium is where the supply and the demand cross. That's the intersection. And that is when the consumer and the producers are happy and they both benefit.